Hello. Sorry, pop-ups appearing on my screen as I try to talk to you. Good afternoon. Hello, everybody. Welcome back. So, lesson number 26, going deep into R now. So yesterday, we talked about packages and how to install packages. And we did indeed do some package installation. We started by installing Bioinformatics Manager because what we wanted was a single unified way of installing packages, regardless of whether they came from CRAN or whether they came from Bioconductor or anywhere else that packages may come from. And Bioinformatics Manager gives us that. It gives us this install function which we can use to install packages from anywhere. And then what I wanted to do, or what I did do, in the kind of remaining time yesterday afternoon was we looked at some real world data. So we looked at this data set called the Golub dataset, which is a leukemia microarray data set, which has been very widely used over the years for demonstrating functionality, especially in R, especially in Bioconductor. And we used that data to, at the very end, to make a plot. We made a box plot and then a violin plot. And I said that we would come back today and I would explain in a slightly more detail how the plotting works. So how we go from data, and the Golub data is a matrix of doubles, and I said that we would talk about how we went from that data through to the plot, which I realized I did very quickly yesterday afternoon in a little bit more detail. So that's kind of my aim for today, is to talk a little bit more about Ggplot and how it works, the philosophy behind it, and how we can use it to turn data into really quite pretty plots quite quickly. Okay, so that's the aim behind today, is to try and talk a little bit more about those things. So let's just start by refreshing our memories of the little bit of code that we wrote yesterday, and just tidying up a little bit as well. So let's turn off my cover image, and there we go. So there's the plot that we made yesterday. So as you remember, this is a what's called a violin plot, and actually these don't look very much like violins in this instance. So the idea behind a violin plot is it's like a box plot. It's showing the distribution of the data. So the shape of the coloured in block here on the left and the right is showing the distribution of the data, but as well as just showing like a box plot does, the range, the sort of interquartile range of the data and where the median is and so forth. The violin plot actually tries to show you the distribution of the data as well. So it gets wider where you've got more data points and gets narrower where you have fewer. So in a normal distribution, so a bell curve of data, you would see that it would narrow towards the top and the bottom and would get fat in the middle. So that's what we're seeing. That's what we're kind of observing here. Not necessarily normally distributed data. Although we've not got very many, observations here, so it's difficult to say whether it's normally distributed or not. But we're seeing the distribution of the data represented in the violin plot. So, and then on the left we've got the code that we wrote to get to that point. Particularly these last few lines here is how we went from data to plot. Okay, so. Just to remind you, this data is in this package called multtest. So we loaded the multtest package using the library function here at the top of our script, and we attached the data to our R session using this call here, the just call to the data function with the name of our data set, which is called Golub. Okay, so the data itself, you've got actually 3 bits of data. You've got 2 matrices. One is a matrix of doubles, and that is the actual data itself. So that's the observations from the microarrays, and that's got 38 columns and just over 3,000 rows. Then we have this Golub dot. Sorry, that caught me by surprise, and I couldn't find my mute button fast enough. Sorry, I apologise for my unprofessional sneezing. Right, sorry, where was I? Yes, the second matrix, this Golub.Genomes matrix. This is a matrix of characters, and it contains the descriptions of the genes. So which genes are which, effectively, which row in the data applies to which gene, and the rows in Golub and the rows in Golub.Genomes are in the same order. So row 1 in Golub.Genomes refers to row 1 in Golub, and so forth. Then the final bit, the third bit of this data is this vector Golub.Cl, and that is the classes of the samples. So that is that vector has the same length as our matrix has width. So the matrix has 38 columns, and that vector is of length 38, and that's because there's 1 entry for each column in our matrix. And telling you whether that particular sample is class 0, which, as we learnt yesterday, is ALL, or acute lymphoblastic leukemia, or class 1, which is AML, or acute myeloid leukemia. So that's the basics of the data, and we can explore this data, and we did briefly explore this data in the same way as we would do any other data set. So it's a matrix, so we can find out what its dimensions are, how many rows it has, how many columns it has, what its dimensions are in rows and columns. We can extract data from it, we can subset it using square brackets. So we're using square brackets here in the numerical notation to extract particular items of data, or we can use relational expressions like this Golub CL = 0 to filter your data on the results of a relational expression. So there we're only pulling out the columns for the ALL samples, where the Golub.Cl is 0. Okay, so that's this data, and we explored that data a little bit, and then I went on to draw this plot. And so this, from line 25 to the end, is how we plotted. The CCND3 expression as a violin plot. And so at this point, I'm going to step away from R for a few minutes just to talk about the grammar of graphics and what we mean by the grammar of graphics, and how Ggplot 2 particularly applies these principles to present data to you in a visual way. Okay, so we talked yesterday about what makes data tidy, and how we can produce tidy data in R that we can use within this thing that we called the tidyverse. Okay, we'll come back to this in more detail later, but this is the kind of first big principle of working with data in R, is understanding what tidy data is and how we can make data that we have tidy. I'll come back to this for this particular data shortly. So the second big principle that I wanted to talk about in relation to working with data in R is this thing that we call, that's referred to as the grammar of graphics. Okay, so what's a grammar? So what's grammar? Grammar is just a set of rules, basically, right? So grammar in language is a set of rules that govern the usage of that language. So grammar in graphics is exactly the same thing. It's a set of rules that we can apply to govern producing any kind of graphics. Okay, so Ggplot 2, so the GG in Ggplot stands for Grammar of Graphics. So it applies these principles in order to produce visualization of data. So for the way that the Grammar of Graphics works in terms of Ggplot anyway, is that you provide three, I think it's three things effectively. So the first thing that you provide is the data. Okay. So that's the first thing, that the first kind of thing that you need to be able to provide to your plotting library. So in our case, Ggplot 2 here is the data. So you provide the data. Then what you need to do is you need to define what are called the aesthetics. Okay, so the aesthetics are rules for mapping variables in your data, and remember that the variables are the columns in our tidy data. So the aesthetics are the rules for mapping variables in your data to visual elements in the resulting plot. Okay, so that's the second thing. Aesthetics can be applied globally or they can be applied locally, and I'll show you what I mean by that shortly. Okay, then finally, the third thing that you need to do is then to provide what we're going to refer to here as the geometry. So this is your plotting rules. This is the way that you want to visualize that data. So do you want to see the data as points on a graph? Do you want to see it as we've seen already, box plots or violin plots? Do you want to see it as tiles of data? There's all sorts of ways in which you can take. Do you want to see lines? There's loads of different ways of taking data and representing it visually. And so the geometry is the way that we define that. And Ggplot particularly, Ggplot 2 particularly, allows us to do this in a layered way. So you can define lots of geometries in Ggplot, and it will give you those layers on top of one another. So the way that this works then is initially we make a call to this Ggplot function, and we provide Ggplot with some data. Okay, so data equals, we'll say df, so some sort of data frame. And that's at the heart of it. That's all you really need. That gives Ggplot some data to produce, and this will even like this will try to produce a canvas. Actually, it will fail because it doesn't know what x and y coordinates to use at this point. So in order for this to work really properly, you need to provide not just the data but some base aesthetics. So some idea of a mapping between the variables in your data, that is the columns of your tidy data, and the aesthetics of your plot. So Ggplot does this with a function which you can nest within the Ggplot function. It's called AES. Okay, so this is the function which lets you define aesthetics. And the smallest set of aesthetics that you need in most plotting circumstances are the x variable, so x equals something, and the y variable. To say to Ggplot, okay, this is my x-axis and this is my y-axis. So you're going to select variables from your data frame to present as x variables and y variables. Okay, we had the example yesterday where we had the expression data in one column and we had the sample class data in another column, and that was our x and our y, and I've done that the wrong way around, sorry. Class data was on the x and the expression data was on the y, and that's what we did. And then if we run this command, then this will produce a canvas for us to plot on with some axes. Okay, so this will give you just the axes where x will have the range of the expression values, y will have the range of the classes in the data. So this will have 2 points on it, and this will have whatever the range of the expression data is in it, with no data plotted on it at all, because we've not said, at the moment we've applied some data and we've supplied some data and we've supplied some aesthetics. So we told Ggplot how to map some elements of that data into some visual information, but we've not actually applied a geometry. So we've not said to Ggplot, this is how we want you to display those aesthetics. So in order to do that, you have to add layers to your plot. So the axes is like the base layer. That's the first thing that's plotted. And then to add additional layers, you use the plus operator. So you add layers on using a plus. And the name of layers for what we're going to be doing immediately anyway, the name of our visualization layers, the name of our geometries will always begin with geom. So it'll be geom underscore something. And whatever the thing is that you want to plot will be the name of your geom. So geom point, geom box plot, geom violin. These are all different geometries that we can apply to the same data. And we can keep adding layers. So you can add more geometries if you want to, and Ggplot will overlay them on top of each other. So if you began here with, if you made this one a box plot, then that's what Ggplot would draw. It would draw you a box plot. And then if you then added to that a second geometry, geom point, for instance, then R would draw the points over the top of the box plot, because it would add a layer over the top. If you did it the other way around, if you did the points first and then the boxes, it would draw the points underneath and then it would draw the boxes on top. And the boxes quite often would obscure the points. And you can keep going. You can keep adding geometries if you want to. And hopefully what will become clear as we use this more, and we will be using Ggplot as we go along to produce visualizations, I think. As we continue to use it, we will find that you can use if you've got, especially if you've got examples to work from, but if whatever you can almost think of to do with data, you can produce that visualization in Ggplot if you can figure out how. It does really, really help to work with examples. You can always find examples online. So Google is your friend in lots of ways in this kind of thing. So if you want to look for examples of how to generate particular visualizations, then Google will certainly help you. And sadly, it's on my desk at work because I use it so much. But there is an excellent, really excellent book. Here you are, called the R Graphics Cookbook. So this is a phenomenal book which just has loads and loads and loads of examples of visualizations in R, and those visualizations are produced in Ggplot too. So pretty much it's actually really good as a physical book because you can flick through it and look for the examples that you want. Although you can browse it here online. You can browse it here and find examples of different visualizations that you can produce. There you go. This is actually using base graphics. It will move on to Ggplot at some point if we work our way through it. There you go. There's a Ggplot graphic. So although the examples are great online and it can be really useful to look through, and it's great that it's available online in this way. It's actually, as a physical book, it's really useful to be able to flick through the pages and try and track down an example of the kind of visualization that you want. And then if you can find that example, find the way that example works, then quite often you can as long as you kind of know what you're doing, you can work back from the example in order to apply it to your own data. So this is how I produced that visualization so quickly yesterday afternoon. And we'll just go back now to that graphic, and we'll take a look at the way that I produced it. And then I'll extend this. I'll make it slightly more complicated in order to illustrate some other features of Ggplot and also of tidy data. So in order for Ggplot to work, you need to have your data in a data frame. So to begin with, our data is not in a particularly convenient form because it's in a matrix. And also we don't want to give the whole matrix to Ggplot if we just want to plot a single observation. So we're plotting out one single gene here. So the first thing that we did in order to generate this plot is we pulled out just the observations from the matrix that we wanted to plot. So we're interested in plotting this gene 1042, okay, so the 1042nd gene in the matrix. So that's the 1042nd row. So we can subset our matrix using just an integer to say, well, this is the row that we want. And what will happen here is that R will then extract this row as a vector, because each row of in fact that's true of each column as well, of your matrix is a vector. So if we just run just this extraction code here, you'll see that we get a vector of length 38, a vector of doubles of length 38. That is the 38 observations for gene 1042. So we've saved that as a vector. We've stored it as this variable ccnd3exp, ccnd3 expression. So that's a vector. Okay. So then the second thing that we want, the second variable that we want for our plotting, so we want to be able to plot the expression, but that's not enough on its own. We also want to be able to separate the expression by the two classes of sample in our expression table. So we've got these 27 ALL samples and these 11 AML samples. So we want to be able to separate those out. So we can see the expression of the ALLs separate from the expression of the AMLs. So we need a second column, a second variable in our tidy data frame. And that second variable is the class, the Golub Golub.cl effectively, whether the samples are 0 or 1. But we wanted to be able to label those correctly. So not just 0 and 1, but ALL and AML. So we generated a factor. And that's because our data can take one of those two levels. It can either be ALL or AML. It can't be anything else. So it's categorical data. And categorical data in R is best represented as a factor. So we created a factor from our golub.cl vector here. So we fed that in as the argument as a factor. We defined the levels as 0 and 1, and we defined the labels so that we could label all of our zeros as ALL and all of our ones as AML. So that's a useful thing to be able to have. And then because we need to pass our data, so there are two variables. And that's all. In order to generate this plot, those two variables are all that we need. That's all the information that we need. We need a position on the y-axis, which is the expression of that gene in any given sample, and we need to know which class the sample falls into. We need to know whether the sample is an AL or an AML. So there are two variables, but we need to represent those two variables in a tidy data frame. So let's remind ourselves of what a tidy data frame looks like. And I'm just reloading my whiteboard, sorry. I don't know why it failed in the interim. So a tidy data frame, if you remember, we had 3 rules for tidy data, which is that each variable has its own column, each observation has its own row, and each value has its own cell. And so we've got 2 variables here. That's the expression and the class of the sample. There are 2 variables, and we have 38 observations. So each of our samples has an observation for each of those 2 variables. So here we go. Here we are. That's our rules for tidy data. And this is what our tidy data looks like. So we've got 2 variables. So we need a data frame with 2 columns, okay, and 38 rows. And then we've got our 2 by 38, and everything in there is a value. In answer to Graham's question, whether it's ALL or AML is not encoded in the data itself. That's information that I've brought in externally. I'm afraid it's not described in the dataset that as we've downloaded it. I know from the documentation on the internet, and I'm pretty sure it's in a vignette somewhere, that the 0's are ALL and the 1's are AML. Okay. Actually, I can show you the. Here we are. There we are. So this is the documentation for the Golub dataset here, which you can see comes from the malt test package up here in the top right, and this describes the data. So here, the description of golub.cl here is a numeric vector indicating the tumour class, 27 ALLs code 0 and 11 AMLs code 1. So the documentation is out there. And we can almost certainly get that documentation in R as well by searching the help files for it. Right, so we've got these 2 variables which we want in a data frame as 2 columns, and that's what we're constructing here with this call to data frame, the data frame function here. So each argument of data frame is a column, and each column is expected to be a vector of the same length. So in this case, we've got 2 vectors of length 38, and we're setting those as our 2 columns. If we do it like this by default, then the name of the vector variable becomes the name of the column. We could change this if we wanted to. We could say expression equals that and class equals that, and that would change the column names, the name of the columns in our data frame. But we need to know the name of those columns because that's how we refer to the variables in Ggplot in a second. Okay, so this is constructing our data frame here. If we just type df in the console, it will print out that data frame for us. So you see it's got 38 rows, it's got 2 columns. The first column is called, we've now called expression, and that's our observations, our expression observations. And the second is class, that's the class of the samples. Again, that's our class observation. So there are 2 variables in 2 columns. So that's what we're passing into Ggplot. So when we make our call to Ggplot here, we are passing in data, which is our data frame. Okay, so that's the beginnings. Let me just separate this off for a second. And then we're defining our aesthetics. Okay, so the aesthetics here, this is the simplest way of doing it. We're giving it an x variable and a y variable. So we're saying one of the variables in our data frame we can map to x, and in this case that's going to be our class variable. So that's the column of our data frame, because remember our variables are in columns because our data is tidy. Okay, so our class variable is our x-axis. So that's the separation that we want on the x-axis between our 2 different types of sample. And then our y-axis takes the expression variable. So that's the level of expression for each of our samples, for each of our data points, each observation. So that's our two aesthetics that we want to set at the moment: the x aesthetic and the y aesthetic. Okay, and we can generate a plot from this. So we can just run this, and this will produce our canvas, and our canvas will have axes because we've told it what we want on the x and what we want on the y. So this is at the base layer of our plot. Okay, so it's got an x-axis and it's got a y-axis, and that x-axis and y-axis have magnitude because we've told it which variables we're going to visualize on those axes. But we've not yet told it how we want to visualize those axes, how yet we want to present our data in the plot. So to do that, we need to add a geometry as well as an aesthetic. So we can save this as well. Rather than plotting it immediately, we can save it to a variable. Okay, so this will save our base layer, our canvas, into a variable. It won't plot it at this point. So if I clear my plots, and like the environment, you have a little sweepy brush here, which will make all of your plots go away. Okay, so I'm going to clear my plots, and then I'm going to set the results of this ggplot call to a variable. And what you'll see is this time it won't produce a plot. Okay, because it's like the difference between doing 5 and x equals 5. Okay, so if I just run a line with just 5 on, R in the console will print out 5. If I run x equals 5, so if I set 5 to be a variable, if I set a variable to take the value of 5 instead, R doesn't print anything out to the console because I've stored the variable, but I've not asked for anything back. So that's exactly the same as what I'm doing here with ggplot. So if I just run ggplot on its own, then it prints the results. And the results of doing that is it produces a plot in my plot window. But if I save it to a variable, then that doesn't happen. I don't get the actual plot produced on the screen. Okay, so what I can then do is I can add layers to this plot that I've saved. So I can do G, and then I can add a layer to it. So let's start by adding a box plot. Okay, so geom box plot. Okay, and because I'm not saving this, I'm not making this equal to a variable. This will get printed. So there you go. That will be printed as a box plot. Okay, I could also save this to a variable. I could recycle G, so I could overwrite G, or I could save it as a new variable. So I'm going to call it G1. Okay, so that saves it as an additional variable. If I want to see G or G1, then I can just type. If I put in the console just G and press enter, then it will print G. So it shows me the value of G. Well, the value of G is this plot. It's this canvas, the kind of base plot that I want. I can also print G1, so G1 also contains the box plot because I've added that layer over the top. Okay, and then I can continue to add layers to this. So if I wanted to, I could add an additional layer. So I'm going to make this G2 this time. So I can add an additional layer to G1. I can add, let's add a point layer. Okay, so this will visualize my data points, not as a box plot, but as individual points. So it will show me, it'll essentially be a scatter plot. Where the x value is either ALL or AML. So points will appear in one of two places horizontally, either here or here. And the x value is whatever the expression is at that point. So you'll get a line of points along the ALL line and a line of points along the AML line. Okay, so let's run that line. We've saved that to this G2 variable, and now we can print G2 like that. And you can see the points there over the top of the box because we added the points layer second, but they're all in a single line, and that's because we've asked for the points. So the x value for all of these points is ALL, so they've all been presented at the same place. If we did this in the other way around, so if we added so if we did G3 equals G plus geom point, so add the points first and then add the boxes, then this will write the boxes over the top of the points. And so assuming that these boxes are filled in, which it looks like they are to me, it looks like they're filled in white, the boxes will overlay the points and you won't be able to see them anymore. Okay, so let's run that and then let's have a look at G3. There you go. So that's what I predicted would happen. So we've drawn the points first, and then we've drawn the boxes over the top of the points, and so the boxes are now obscuring the points. There are ways and means of fixing that, and we can talk about transparency if we want to. I just wanted to talk a little bit more about aesthetics as well. So let's go back to producing this all in one go. I'm just gonna move that out of the way for the minute because I think that's confusing matters. Right, okay. So let's go back to this command, and we're going to produce it so that this prints directly to the screen now rather than saving it as a variable. So here we've set our x and our y aesthetic, and we've set the x and y aesthetic globally. So it's been set in the call to Ggplot 2, which means that all of our geometries will inherit those aesthetics. So they will all of the geometries that we add, unless we tell them differently, will have an x aesthetic and a y aesthetic set to be the same values. And we can set other things globally as well. So we can set other aesthetics globally if we want to as well. So we could use the class to set the color as well as the x position. Okay, so we can set color equal to class. And then when we add a geometry, so that's what I'm going to do. I'm going to add, so the add has to be, I'm separating over two lines here, but the add has to be at the end of the first line. I'm just going to make this just a touch wider just so you can see. So if I put the plus down here, Ggplot won't find it. It won't know about it. It has to be at the end of the first line. So you have to put the plus there at the end of the line. That's just a let's just treat it as a rule, okay? So if we add geom box plot, and then if we add geom point as well, both of these geometries, both geom box plot and geom point, will inherit this aesthetic, this color aesthetic. So what you'll see is the box plot will be colored according to the class, so whether things are ALL or AML, and the points will also be colored according to the class. This may not behave quite the way you expect. So color for the box plot means the outline. So there you go, that's what we're seeing there. We're seeing the outline of the boxes colored in according to this class variable, and we're also seeing the points colored in according to the same variable. So both of our geometries are inheriting that aesthetic. We might not want that to be the case. We might only want one of our geometries to be colored in. So maybe we only want the boxes to be colored rather than the points. Maybe we're fine with the points being black. And in that case, what you need to do is define the aesthetic within the geometry itself. So rather than defining the aesthetic globally in the call to ggplot, what you do is, so we'll take that out of there, you define the aesthetic within the call to the geometry. So here we're drawing this box plot geometry, and if we want to change the behavior of that, if we want to give that its own aesthetic, we can. Okay, so we can put in here, we can put an aesthetic that's specific to the box plot the box plot geometry. So we can give this color equals class in here. Note that color here, I'm spelling it the English way. Actually, this is actually officially the New Zealand way. Ggplot was originally developed by a New Zealander, and so he allowed you to spell color the way that they spell it in New Zealand, which is the same way as we spell it in England, in Britain. You can also spell color the American way, should you be used to that, and this will work as well. So you don't need to remember your native spelling of color. You can choose either color with a U or color without a U, and both will work. Okay, so in this case, what's going to happen to our plot here now is the boxes will still be colored in, but the points won't be. So the points will go back to being black. Okay, because that that aesthetic is no longer global to our whole plot. It's specified only within the box plot geometry, not within the point geometry. So the points don't know what color to make themselves, so they make themselves black. We might just want the points colored in, and you could do the same thing. You could take the aesthetic out of the box plot and into, and into the point. Let's undo that. X and V. There you go. So this time the box plots will go back to being black, and the points will change their color according to the class. So there you go. That's that happening there, which is what we described. Okay, so now the box plots are black and the points are colored in. One final thing here before we start thinking about violin plots. Applying color to box plots is not always what you want to do, because that just changes the color of the lines. You might actually want to change the color of the boxes themselves, and to do that, the variable that you give to aesthetic is not color, it's fill. So how you fill in the boxes, and this will actually color in the boxes. We're going to leave color to be the default, so the lines will remain black. Okay, so there you go. That is now filling in your boxes rather than changing the color of the outlines. And we've left the points as the color that they are. If you colored in the points, they would start disappearing at this point. So if they were overlaying the boxes and they were coloured in the same colour as the boxes, then they would disappear. It would be like drawing them underneath the box. Okay, so that's how the configuration works. Incidentally, if you want to change the colour of the points but not have it be dependent on the data, you can do that, but you do it outside of an aesthetic. So the way to think about it is an aesthetic is applied variably. So it's applied to a variable. So for different values of that variable, the aesthetic will take different values. If you want to apply something globally, so if you don't want your points to be black, if you want them to be some other colour, then you apply that setting outside of the aesthetic. Okay, so colour equals blue. Right, we'll change the colour of your points, and it will change the colour of all of your points, not just the ALL points and the AML points differently, but it will change all of the points. So this will make all of the points blue. So there you go. That's what that has done. So this is applying a setting outside of an aesthetic to get them to change, not dependent on the data, but to get them to change regardless. I'm going to take that away because I don't really like it. Okay, I see Bernard asking, how do we change which colours are used? So Ggplot has this default colour palette, where what it's trying to do is pick colours that are contrasting as far apart from each other on the colour wheel as possible. So as you add more, if you had more variables, you would get more colours, and they would be picked in a relatively sensible way. It is possible to define the colours that you want for your plot. I don't have it to hand, and I feel like I should do. Bear with me 1 second while I find how to do this, because I suspect, like most people, I don't actually, a lot of the time I don't know off the top of my head how to do these things, and so I have to look things up as well, and I wasn't quite expecting to have to do this right now. Here we go, maybe. Hold on 1 second. No, that doesn't help. Sorry, I'm looking stuff up live while I'm trying to talk to you at the same time, which is never a straightforward thing to do. It is scale fill manual. Somebody there is quite right. I'm just looking for the usage. Let me look it up. Here we go. Yes, so the answer is you have to add a setting to Ggplot, which is called scale. So you change the scale. So scale fill manual lets you change the scale, and you define your colors with palette, I think. Gosh, trying to do this live is never sensible. There we go, values. So values equals. So you need as many values as you've got variables. So so we could say just use red and blue, right? Which are slightly bolder colors than we're using here. So there you go. Scale fill manual. Give it the number of values that you have, classes in this case, and it will then color in according to those. There you go. According to those values that you've given it. If you want to change the color, then it's the same process, but it's scale color manual instead of scale fill manual, and it would achieve the same ends. There you go. So that's outlining them in red and blue rather than filling them in red and blue. Okay, so that is how to pick your own colors. It can get complicated, and it can get very complicated very quickly. We'll come back to colors later another time, but hopefully that gives you an idea of how to go about that. We'll change this back to fill, and we'll get rid of that line for now. I'll put it in as a comment, actually. Pick your own color scheme. There we go. Okay, so the final thing that we did, rather than presenting a box plot, actually we did two different things, and we changed these two geometries. So the first thing is that rather than presenting a box plot, we presented a violin plot. You can also change the box plot. You can add what are called notches. So if you do notch equals true, then you'll get a notched box plot, which will pull the boxes in at the median line, which is, I don't particularly like, but that is a representation of the data. But we wanted to present a violin plot instead to show the distribution of the data across the range, as well as just the kind of interquartile range. So we changed our box plot geometry for a violin geometry. So this will present it as a violin plot rather than a box plot. So there you go. That's the violin plot, which some people prefer. I don't mind a box plot, especially with kind of normally distributed box plot data. A box plot's just fine. But violin plots give you a little bit more information. And then the final thing that we did is, rather than having all of these points in a single vertical line, we wanted to alleviate some of this overplotting where the data gets dense. And we did that by introducing what's called jitter. So jitter is a bit of variation on the x-axis, basically. It is taking the points that are all at a fixed point on the x-axis and varying them ever so slightly to give you to allow you to see this kind of overplotting that we're observing here, where the data gets dense. You can do it in two ways. You can give I'm pretty sure there's a jitter argument for geom point, possibly, but the easiest way to do it is to use the jitter geometry instead. So replace the points geometry with the jitter geometry, and that will add jitter on the x-axis by default. The default width of the jitter, so the amount of jitter that it adds, is quite a lot. So you end up with quite a wide spread on the x-axis, like that. So what I think can be difficult then is, you can tell the difference between the ALLs and the AMLs here, but if you had lots of violins along the x-axis, your points can get quite close together. So the way to define your different categories a bit more is to reduce the width. So you can say you can pass an argument to geom jitter, which is width, and this isn't an aesthetic. This doesn't vary with the data, so this is a fixed thing. So we're not doing it inside an aesthetic function. So we can set the width to be a smaller amount. So by default, the width I think is 1. So you can set it to be a smaller amount, so that the points become a bit more condensed across the x-axis. So I'm going to set it to be 0.2. And now we've recapitulated this, I'm just going to delete this little bit of code from down here. Okay, so that gives us back the plot that we had yesterday. And there are a whole set of defaults here that we can override if we want to. So all of the labeling happens by default. So the x-axis and the y-axis label are added by default from the name of the columns in your data frames. So the label on your x-axis is the column name of your X aesthetic, and the same for the Y-axis. We can override those if we want to. There are settings for all of these things that we can override. So we can use the function xlab to change the label of the x-axis. So you see that the label on the x-axis changes to the text that I put inside xlab. You can give it a title. So ggtitle allows you to give a nice plot, right? So that allows you to give your plot a title. So there you go, we've given it a title. If you don't like the default theme with this grey background, and a lot of people don't, there are Ggplot themes, which a certain number of which come installed by default. So they all start with theme. So if you type theme and then underscore, you get a list of them here. So these are all themes that you can get, that you can use, which are different. A lot of people like theme BW, which is a black and white theme, which gets rid of the grey background on the plot. I use theme BW a lot because I prefer that aesthetic. I prefer that look and feel to the default. The other one that a lot of people like is minimal, which is like BW but even more kind of stripped down. Okay, so you can do a lot of styling as well. So I'm going to leave this as being theme BW because that's my preferred, and I'm going to get rid of that X label because that doesn't make much sense. Okay, so there's my final plot. And I realise that I've been talking for a very long time just to recapitulate what I did in 5 minutes yesterday. But I think it's quite useful to look at this in this way. So what I was going to do was move on to do a couple more complicated plots. But actually, I think given the time and given the amount of time I've been talking, I think it's going to be best to move on to do that tomorrow. So what I'll do tomorrow is I will look at how to plot not just the expression of one gene, but the expression of, I'm going to do 2 genes, but you could extend it to be lots of genes if you wanted to. So we're going to look at how to plot more than one variable out of our data. And produce nice, sensible looking plots. So we're going to do that tomorrow. And I think I might also use this data set as an example to show you how to plot, to make a PCA plot as well. Principal components analysis is a thing that people like to do a lot of. We can use this data as a way of producing an example using the data and Ggplot to produce an example PCA plot. So I think we'll do that tomorrow as well. Okay, so I realise I've talked for a long time, but I think it really was worth going through the details of that and trying to illustrate in slightly more painstaking detail how Ggplot is actually working to generate graphics. Because the more that we understand about the grammar that we're using here, the more that we can use that to produce more and better plots later on when we're working with our data in anger. So I think that's the plan for tomorrow. And then I think on Friday, we will turn our attention to importing our RNA-Seq data, okay? The one thing I'm going to do before I leave you is I'm going to save this script. So I'm going to hit save. And I'm going to create a new folder, which I'm going to call week 6, because that's where we are now, which has magically dropped itself into the wrong place. That's irritating. Hold on, I'll go back. I'll try again. Week 6. And I'm going to save this in week 6, and I'm going to save this as Golub plotting. Again, RStudio will add the .r extension by default. And I will upload that script to GitHub once I've signed off here. So I'll make that script available to you, so you can get a copy of the same code as I've been using. And then, as I said, tomorrow we'll go on to do some slightly more advanced things. And then on Friday, we'll look at importing our RNA-Seq data so that rather than using this example data set, we can start to use our own data to explore some plotting and to explore some analysis. Okay, with that, I will sign off. So thanks everybody. Some nice comments and questions today. Made me think. I like to be kept on my toes, thinking on my feet. And I will see you all tomorrow. Stay safe, keep well. See you tomorrow afternoon. Bye, everybody. Bye.